In the question, it is asked that dilute hydrochloric acid reacts with calcium carbonate to make carbon dioxide gas. The apparatus shown in the diagram can be used to follow the progress of the reaction. The carbon dioxide gas leaves the flask, causing the mass shown on the balance to decrease. Now plan an investigation using the apparatus shown in the diagram to find out how the temperature of dilute hydrochloric acid affects the rate of reaction. Your plan should include how your results will show how the temperature of the dilute hydrochloric acid affects the rate of reaction. Now here in this question, we are given a reaction between calcium carbonate, which is CaCO3, and dilute hydrochloric acid. It will result in the formation of calcium chloride, which is CaCl2, plus carbon dioxide gas is also given out, along with water, which is also formed. So by writing 2 over here, we can balance the equation. So here we have 2 reactants, calcium carbonate and HCl. And what do we have to do? We have to follow the progress of the reaction, and we have to see the effect of temperature. What is the effect of temperature on the rate of reaction? For that, we will be using dilute hydrochloric acid. We'll take hydrochloric acid at different temperatures. Now, we have learned about rate of reaction. That rate of reaction is the time taken by the reactants to be converted into products. Or you can say that the reaction rate is the measure of how fast a reaction takes place. And it can be measured by using the formula that rate is equal to change in concentration divided by time, where the change in concentration means that either it's an increase in the mass of the products or decrease in the mass of the reactants. So, and there are 2 methods by which rate of reaction can be measured. First is by measuring the decrease in mass, which is also asked in the question. And second one is by collecting volume of the gas evolved. Now for the measurement of rate of reaction by measuring the decrease in mass. For that purpose, as you can see in the diagram, there is a conical flask, and in the conical flask, both the reactants, the acid and calcium carbonate, are taken. The flask is fitted with cotton wool, because as we have seen that in this reaction, when acid and calcium carbonate, they will react together, they will produce carbon dioxide gas. Carbon dioxide gas can easily move out through the cotton wool, but we have to keep the cotton wool at the neck of the conical flask to avoid or to prevent the acid spray. This conical flask is kept on the balance to measure to check the mass, or whether it increases or decreases as the reaction proceeds. Now, we'll see that as the chemical reaction proceeds, the reaction is fastest at the start, and then it slows down. And the reactions in which, like this, in which carbon dioxide is given out, this escape of carbon dioxide from the reaction mixture causes the decrease in the mass, and that can be seen with the help of balance and the time duration, because we will be measuring the decrease in mass at specified time intervals. So for measuring time, we need stopwatch as well. Like for example, at the beginning, at the start of the reaction, we can say the total mass of the flask along with its content is, as is shown in the balance, it is, for example, it is 260 grams. So there is no decrease in the mass as the reaction has not started yet. And then, for example, after 1 minute, you get the value or the mass of the flask along with its contents, you get the value of 240 grams. That means that there is a decrease in mass of 20 grams. Then after next 1 minute, the decrease is of the mass of the flask becomes 230. So that means that now there is a decrease of in mass of 10 grams. Next, we get the reading, for example, like we get it 225 grams. So that means that the decrease in mass is of 5 grams. Then we get the same reading, like 225. So now that means it means that there is no decrease in the mass, or we are getting the constant value 0 gram. That means, what does it show? It means that the reaction has stopped now, or you can say the reaction has finished. So this is one method by which you can measure the rate of the reaction. The second method is the measurement of reaction by collecting volume of the gas evolved. For measuring the volume of the gas evolved, we need to have a gas range. So the conical flask is fixed with a gas range, which is graduated. It has a plunger. So as more and more carbon dioxide will come, the plunger will move back and you can calculate the volume of the gas. And then in the same way, you can get your readings. Now, when you will plot the graph for example, if you want to show the graphical representation. So over here, when you will plot the graph for the volume of the gas, you have taken it along y-axis and time along x-axis. So you know that at the beginning, you will get a very steep graph. You will get a curve which would be very steep, starting from 0. It's because over here at the beginning there was no gas, but then as the reaction proceeds, the amount of carbon dioxide or the volume of carbon dioxide increases, and then you see that after some time the value becomes constant. So this is kind of graph that you will get. This is the steepest point. So the steepest point shows that the reaction is fastest at the start. And over here, you can see the steepness is decreasing. So as the steepness is decreasing, so that means that the reaction is slowing down. And when the line becomes like almost horizontal or straight, so this shows that the reaction has finished now. So this is the kind of curve that you will get. But in the question, they have asked you, okay, you have hydrochloric acid and you have to perform the experiment. You have to repeat the experiment by taking acid at different temperatures. So that means that you will get different curves, or you will get curves for different temperatures. So if, for example, you say that this is the graph or this is the curve that you have got at a high temperature at 100 degrees Celsius. So, and now if you perform the same experiment at a lower temperature, so when you perform the experiment, you will perform the experiment at lower temperature. So at lower temperature, the rate of reaction will decrease, because rate of reaction increases with the increase in temperature. But as you perform the experiment at lower temperature, So you will get a curve, a similar kind of curve, but like this, showing that the rate of reaction has decreased. So this you might have performed the experiment at 0 degrees or 25 degrees Celsius. So this is the curve that you will get at a lower temperature. So the curve in the red line that I've made, you will get it at high temperature, but you will get a lower curve at lower temperature. In the same way, for if you have to plot a graph for the decrease in mass of the flask contents, then again you have to perform the experiment twice by taking hydrochloric acid at a high temperature and a lower temperature. So at the higher temperature, over here, for example, if this is the mass of the reactants of the reaction mixture, now over here you'll be getting a falling curve because the mass is decreasing. See, the mass is going down and the steepness of the reaction shows that the reaction is proceeding at a faster speed. Now it's getting slower and it's now line has become horizontal. So that means, or it has become constant, showing that the reaction is no more taking place. So this is the graph that you will get at a higher temperature. The same kind of falling curve you will get at lower temperature, like this. The rate of reaction would be slow. So this is the graph that you will get at lower temperature. So in this question, you can plan the experiment. You can plan the experiment by taking the measured amount, known amount of calcium carbonate in the flask. So first you can take measured or known amount, measured amount of calcium carbonate in conical flask, and you can also take measured volume of the acid of hydrochloric acid in dilute form. Then you can mix, you can combine, or you can add acid, or you can mix both of them. You can add acid in calcium carbonate for the reaction to take place, and you start the noting time. As you start noting you can note the starting time, as well as also note the mass of the beaker plus, sorry, not the beaker, the conical flask. Conical flask along with its contents. Then you can keep noting down the decrease in mass versus time, and then you can repeat this experiment with can repeat the experiment with acid at higher and lower temperatures. Just keep the record, or you just record the mass at regular or at a specified time. And then in the end, you can explain it by plotting the graph, or you can show the graphical representation like I have shown you, showing the difference in temperature, the graph that you will get at higher temperature and lower temperature. You can tell that the rate of the reaction, it increases with the increase of temperature. So as the rate of reaction increases, the mass of the flask and its contents decreases in the beginning. As the reaction is faster, so you can at the beginning, and then it becomes slower and slower as it ends.